Hello students, welcome to Shri classes. Let us start lecture number 2, polynomials. Concept number 5, relationship between zeros and coefficients. We are going to establish the relationship between zeros and coefficients of a given polynomial. So consider a polynomial, or I'll write like this: let alpha and beta be the roots of p of x equals ax square plus bx plus c. So alpha and beta are the roots of this given polynomial. Okay. If alpha and beta are the polynomials, then can we express the given polynomial as x minus alpha into x minus beta? This we have studied by factor theorem in the last year 9th standard. If a is a root, x minus a is a factor. If minus a is a root, x plus a is a factor. This you have already studied. And therefore, as alpha and beta are the roots of this given polynomial, then the given polynomial can be expressed in terms of alpha and beta by factor theorem. Therefore, by factor theorem, p of x equals k into x minus alpha into x minus beta. What is p of x? Ax square plus bx plus c equals k times x into x minus beta minus alpha into x minus beta. Here again, ax square plus bx plus c equals k into bracket x square minus beta x minus alpha x plus alpha beta. So ax square plus bx plus c equals kx square minus, once again let me put it to bracket, and finally I'll open the bracket, x square minus into bracket alpha plus beta times x. If I take minus out, it will become alpha plus beta, beta plus alpha, which can be written as alpha plus beta times x plus alpha into beta. Ax square plus bx plus c equals kx square minus k times alpha plus beta times x plus k times alpha into beta. Here k is a non-zero constant. Generally we take a non-zero constant as a product of the factors. So ax square plus bx plus c equals, we have got kx square minus k times alpha plus beta times x plus k times alpha into beta. Let us compare the coefficients of and constant term on both sides of the equations. On comparing coefficients and constant term on both sides of the equation, we are comparing the coefficients and the constant term on both the sides. On comparing coefficients and constant term on both sides, we get, see here, a equals coefficient of x square is a, coefficient of x square is k, implies a equals k. Coefficient of x is b, coefficient of x here is minus k times alpha plus beta. Constant term is c, here it is constant term is k into alpha into beta. Now this implies here see here alpha plus beta equals from here itself alpha plus beta equals minus b divided by k. This k I am taking it downward, so alpha plus beta equals minus b by a. How did I get this a? Actually k equals a here because a equals k, isn't it? So here for your information I'll mention a equals k. Reason is a equals k. Therefore we have established the relationship between these are the coefficients and these are the sum of roots here. So sum of roots is equal to minus b by a. What about here? From here I can conclude alpha into beta equals c by k. Therefore alpha into beta is equal to c by a, implies c by a. Why it is so? Because k equals a here I have written, isn't it? So the two important relationships that I have established over here is, one is the sum of zeros here and the product of sum of zeros and the product of zeros, isn't it? So I think you can note it down. So finally here I can write sum of zeros equals alpha plus beta equals minus b by a. Therefore alpha plus beta equals, what is this b here? B is a coefficient of x here, minus coefficient of x the whole divided by coefficient of x square, Similarly product of zeros is equal to product of zeros alpha into beta equals c by a, which is c is a constant term, a is a coefficient of x square. Therefore constant term the whole divided by coefficient of x square. So these are the two important relationship which you have established. So note it down first. So we'll write now important conclusions, sum of zeros and product of zeros, and also one remark I am going to write it. Let us see that. So first let us establish the relationship between the quadratic polynomial and the relationship between the quadratic polynomial and the zeros. What we have checked right now is only with respect to quadratic polynomial. Okay, the degree is 2 here, and after solving the numericals I'll go to the cubic polynomial, where again we'll establish the relationship between coefficients and zeros. So for the time being I'll continue with the quadratic polynomial and we'll solve a lot of numericals, and then finally we'll go for cubic polynomial. Okay, so so once again I'll write here, if p of x is a quadratic polynomial given by ax square plus bx plus c, and if alpha and beta are the zeros, if alpha and beta are the zeros or roots, then sum of zeros alpha plus beta, or I'll write like this, sum of zeros equals minus coefficient of x the whole divided by coefficient of x square, implies alpha plus beta equals minus b by a. This is one formula. And also product of zeros, is equal to constant term the whole divided by coefficient of x square. Coefficient of x square implies alpha into beta equals c by a. These are the two important relationships. Now comes the question, if we know alpha and beta, how to form the quadratic polynomial? Second is formation of the quadratic polynomial. From this, see here, in the beginning what we did here, if we are given a quadratic polynomial, we are able to find out the sum of zeros and product of zeros. If we are given sum of zeros and product of zeros, how to form the quadratic polynomial? So, if sum of zeros and product of zeros are given, then a quadratic polynomial can be formed as below. So let polynomial be p of x. Therefore, p of x equals k times into bracket x square minus alpha plus beta times x plus alpha into beta. So this is how we can form. If you know the sum of zeros and product of zeros, you can form the quadratic polynomial by considering a non-zero constant here. K is a non-zero constant. So these are the two important aspects which you must know. Now we are ready for solving some numericals. I think you must note it down and then we'll proceed with numericals. See, for the numericals, what I am doing is I am categorizing for your convenience the entire category of numericals, the entire spectrum of numericals into maybe about 4 or 5 types, and then we'll solve each and every numerical. In each category I'll take about 3 to 4 numericals, and the important numericals also will take it, so that it would be very convenient for students to understand how to solve a particular type of numerical. Otherwise, what happens if we club together all these numericals, it would be very difficult to distinguish between each type of numerical and also to understand. So it is a simple categorization, and that helps you a lot. Okay, so first note it down and then we'll start with numericals. Let me take up the first type here. Find the zeros and verify the relationship between zeros and coefficients. So let me take the first numerical. I am picking up from RDS, of course, which covers from textbook also. So the first sum here, we have to find the zeros and then we have to verify the relationship between zeros and the coefficients. First one, x square plus 7x plus 12. X square plus 7x plus 12. So how to solve this? Concentrate on the method how to solve, how to find out the zeros here, because finding out the zeros, it is very one important aspect. Many students fail to adopt that first step itself. You know, that is the most important step. Let's see here. Let p of x equals x square plus 7x plus 12. Okay. To find zeros, let p of x equals 0 implies x square plus 7x plus 12 equals 0. You cannot find out the zeros without subjecting the given polynomial to 0. I would like to highlight over here. In a graph, what exactly do you mean by zeros? The graph is nothing but, the zeros are nothing but where the x coordinate of a point of intersection of the graph with x axis is called the roots or zeros. At these points, what are the values of y here at these points? These are basically called zeros, isn't it? Zeros. And here y equals 0 here, isn't it? And many times we considered p of x is equal to, say for example, ax square plus bx plus c. Then let y is equal to p of x is the graph. This is what we have written earlier, implies y is equal to ax square plus bx plus c, isn't it? And finally, at these coordinates, y is 0 here. So if I subject it to 0, then ax square plus bx plus c, this will be equal to 0. Then I will be able to find out the coordinates of this one x by splitting the middle term. So what I mean to tell you here is, it is most important. It is in order to find out the zeros of a given quadratic polynomial, you must convert the given quadratic polynomial into quadratic equation. Meaning what? You have to subject it to 0, putting equality sign. The moment you put equality sign and subject it to one more variable such as y or 0, it becomes an equation. And therefore, here what we have to say is this quadratic polynomial, which is an algebraic expression, must be subjected to 0 in order to find out the zeros or roots here. And therefore, to find zeros, let p of x is equal to 0 here. Implies x square plus 7x plus 12 equals 0. Now use the factorization method in order to find out the zeros of this. What is factorization method? That is by splitting the middle term. We'll try to use by splitting the middle term. So here let us see. 12 into 1, 12 I require. I should split into such a way that I should get plus 7 here. So 4 3s are 4 plus 3 equals 7. X square plus 4x plus 3x, 12 equals 0, implies take common here, x plus 4 plus 3, x plus 4 equals 0, implies x plus 4 into x plus 3 equals 0, x plus 4 equals 0, x plus 3 equals 0, x equals minus 4, implies alpha equals minus 4, x plus 3 equals 0, x equals minus 3, implies beta equals minus 3, and therefore alpha equals minus 4 and beta equals minus 3 here. We have got two zeros. How to verify the relationship between these zeros and coefficients? Next. So we have found out here the roots here, alpha and beta. Next is to verify relationship between roots and coefficients. We know the sum of zeros alpha plus beta equals minus b by a. LHS alpha plus beta equals, what is the value of alpha here? Minus 4. Beta is minus 3 equals minus 7. So RHS equals minus b by a. What are the values of a and b over here? A is 1, b is 7, c is 12. So what is the value of minus b by a? Minus b by a is equal to minus b is 7 divided by a is 1, which equals minus 7. So LHS is equal to RHS over here, isn't it? From above LHS is equal to RHS. Now this is sum of zeros. Now we'll go for product of zeros. Alpha into beta, product of zeros is equal to c by a. What is LHS here? Alpha into beta equals, what is alpha here? Minus 4 into minus 3, which equals plus 12. Similarly, RHS c by a. What is c here? 12 divided by a is 1, which is equal to 12. See here, alpha into beta is also equal to 12 and c by a is also equal to 12, and therefore hence verified, isn't it? From above, once again, from above LHS equals RHS, hence verified. The relationship between coefficients and the zeros is verified. Okay, so note it down. See, some in the textbook a little bit different way it is given, that also can be done. For example, directly you can put alpha plus beta is equal to minus b by a, populate the values over here and work out simultaneously LHS, RHS also you can do, but that is working simultaneously LHS and RHS is not preferred. Generally, whenever we have we end up with proving something or to show that or to prove that, generally what we do, take one part, either LHS or RHS, and arrive at the other part. So here I am taking LHS and confirming with RHS. See here, alpha and beta is equal to minus b by a. LHS of this equation is alpha plus beta. I have substituted the values to get as minus 7, and RHS is coefficients, basically minus b by a. Coefficients are b is 7, a is 1, minus b by a is minus 7. So both LHS and RHS are equal. That means sum of zeros is equal to minus b by a and product of zeros is equal to c by a. Hence the relationship between the coefficients and roots is verified. This is how we can write it. So I'll take up the next problem. Note down. Let us take the second problem. Find the zeros of the quadratic polynomial and verify the relationship between zeros and coefficients. F of x equals given 6x square minus 3. 6x square minus 3 here. Okay. So let us find out. First we have to find out the roots over here. Isn't it? 6x square minus 3. Yeah. So to find zeros, let f of x equals 0 implies 6x square minus 3 equals 0. How do you find out here? This can be written as root 6x the whole square minus root 3 the whole square equals 0. Implies a square minus b square, a plus b into a minus b. So root 6x plus root 3 into bracket root 6x minus root 3 equals 0. Root 6x plus root 3 equals 0. Root 6x minus root 3 equals 0. Root 6x equals minus root 3. X equals minus root 3 by root 6, or x is also equals 3 divided by 6 here. So this is equal to under root of minus here. Remember, it is minus here, minus 1 by 2. So therefore alpha equals minus under root of 1 by 2. So let us consider this now. Here in this case here, under root of 1 by 2. Therefore beta equals under root of 1 by 2. We have got it. You got it? So now what is that we have to do? Verify that we have found out the roots here, alpha and beta we have found out. Next is we have to verify the relationship between coefficients and zeros. To verify relation between, to verify the relation, what relation between the zeros and coefficients. So I am writing in a shortcut here to verify the relation. We know that sum of zeros is given by alpha plus beta equals minus b by a. Isn't it? What is alpha plus beta over here? Minus half minus under root of 1 by 2 plus under root of 1 by 2. Okay, this is what it is, isn't it? Which equals, what is minus b by a? Here a equals 6, b equals 0, c equals c minus 3 here. Are you able to understand here? See, if you are getting confused, sometimes what I do here, before I find out the verification result, I can write this equation once again, populate the values of a, b and constant term c, and then carry out this relationship. For example, here I'll write here, first of all what I will do here is, this is a slight modification to the previous sum what I did. To verify the relation, under this condition I'll write here f of x equals 6x square minus 3 implies a equals 6, b equals 0, c equals minus 3. Are you able to understand now? Now I can populate the values here. We know that sum of zeros alpha plus beta equals minus b by a. What is alpha plus beta? Minus half under root of half plus under root of half equals, what is minus b here? Minus 0 divided by a is 0. So this is 0 here and this is 0. hence verified. Is it clear? So I am simultaneously finding out both these values, simultaneously substituting the values of alpha and beta and minus b by a, hence 0 equals 0, hence verified. Also alpha into beta equals c by a. What is alpha into beta here? Alpha is minus 1 by 2 into 1 by 2 equals, what is c here? C is minus 3 divided by a is 6 here. So under root of half into under root of half is nothing but half. Under root of a the whole square equals a here, and therefore this is minus half, which equals minus half. Isn't it? Hence verified. Hence verified. So this is one more alternate way, and next I'll take one more alternate way, which is something like a textbook method. So all these methods are acceptable, but most preferred method is the first method which I showed, taking LHS and RHS separately and concluding that LHS is equal to RHS is most preferred, and many schools follow that method actually. Okay, if I note it down. Third one, given is 4u square plus 8u. We have to find out the roots here and verify the relationship between zeros and coefficients. Let f of u equals 4u square plus 8u. To find zeros, let f of u equals 0 implies 4u square plus 8u equals 0. Take common here 4u, u plus 2 here, which is equal to 0, implies 4u equals 0 or u plus 2 equals 0, implies u equals 0 and u equals minus 2. Therefore alpha is equal to 0 and beta equals minus 2 here. Is it correct? We have taken 4u common here. If you take 4u common, u is remaining, and here it is 2 here. So this is what, see here, this is a typical sum. Some students know how to solve this one, but almost 60-70% of the students will solve by one more method which I will show you, which is not correct actually speaking. This is how students will solve. See here, 4u square plus 8u equals 0, isn't it? Now therefore 4u square equals minus 8u. So 1u cancels, u remains here, u equals minus 8 by 4, therefore u equals minus 2. What is alpha and beta here? I got only one root here. What about the other root? Without that you cannot verify the relationship between coefficients and zeros, and therefore you must be very careful over here. By taking common, we should be able to solve this one, and we will be able to find out two roots here. So this method is not acceptable here. Many of you solve like this, or you take a u common and subject directly to 0, and you keep only, see, other method is something like this. Some students may do something like this: 4u, u plus 2 equals 0, and therefore u plus 2 equals 0 by 4u, which is 0, therefore u plus 2 equals 0 and u equals minus 2. Where is the other root here? This is also a wrong method. You require to find out the two roots over here. Therefore it is very important is take common here, but subject this also to this. What is this process called? It is called a zero product law. By zero product law, the factors of this are individual factors are subjected to 0 over here. Okay, so important, this I hope you are able to understand. Now to verify the relation, to verify relation, you should write clearly. This is, I am taking a shortcut here. To verify the relationship between zeros and coefficient is what your title should be there in your answer script in the exams and all. So here once again I write here, what is that I have taken? F of u equals 4u square plus 8u. Therefore a equals 4, b equals 8, c equals 0. Is it correct? Because these are the coefficients here. We know that sum of zeros equals minus b by a. What is sum of 0? Alpha plus beta equals minus b by a. Substitute the values here: 0, plus beta minus 2 equals minus 8 divided by a. A is 4. So here minus 2 equals minus 2. Isn't it? Hence verified. Similarly, product of zeros is given by c by a. What is product of zeros? Alpha into beta equals c by a. What is alpha into beta? 0 into minus 2. 0 into minus 2 equals, c is how much? C is 0 divided by a is 4, and therefore 0 equals 0. Hence verified. I hope you are able to understand. So let me take the next problem, note it down. So given here is fourth problem. I think it is fourth. Serial number, don't bother. You go on putting the serial numbers. F of x equals 4 root 3x x square plus 5x minus 2 root 3. So to find zeros, let f of x equals 0 implies 4 root 3 x square plus 5x minus 2 root 3 equals 0 implies, I require two numbers here, 4 root 3 into 2 root 3, but minus here. How much this will be? 4 to the 8, 3 is a minus 24. And here I require 5 here. So 4 root 3, 4 into 2, 8. Root 3 into root 3, 3. 4, 8, 3 is a 24. Okay, 24. How do you get here? 5 here. I require 5 here. Minus 24 plus 5. So 4 3 is a 4 3 not possible. 6 4 not possible. 12 4 not possible. Whether it is correct or not, let me check it. 4 root 3 x square plus 5x minus 2 root 3. 4 to the 8, 3 is 24. It is correct. So let me factorize it. 24. 2 12s are 2 6s are 2 3s are 3 1s are. Okay. So try to combine this over here. 4 6, which is not possible. Not possible. 8 3. 8 and 3 is possible. So it is 8 and 3 are possible, which is nothing but here I'll write plus 8 minus 3. Plus 8 minus 3 is plus 5. And therefore 4 root 3 x square plus 8x minus 3x minus 2 root 3 equals 0. Implies what is common out of this one? 4x into bracket root 3x plus 2. Okay, what is common here? Minus, I'll take root 3 into bracket root 3x plus 2 equals 0. Are you able to understand here what I did? It is written as root 3 into root 3 times x. Root 3 I have taken common minus root 3. So this will become root 3x and this minus will become plus here and 2 is common. Therefore implies root 3x plus 2 into bracket 4x minus root 3 equals 0. Implies root 3x plus 2 equals 0. 4x minus root 3 equals 0. Implies x equals minus 2 by root 3 and x equals root 3 divided by 4. Therefore alpha equals minus 2 by root 3 and beta equals root 3 by 4. Now we have to verify the relationship. Let us verify the relationship between, next, to verify relationship between coefficients and zeros. Let us see here. Let me write once again. Given for f of x equals 4 root 3 x square plus 5x minus 2 root 3, a equals 4 root 3, b equals 5, c equals minus 2 root 3. So now we know that sum of zeros alpha plus beta equals minus b by a. LHS here is alpha plus beta. What is the value of alpha? Minus 2 by root 3 minus 2 by root 3 plus root 3 by 4 plus root 3 by 4 here. So what is the LCM here? Which is 4 root 3, and root 3 cancels, 4 to minus 8, and here root 3 by 4 cancels, root 3 into root 3, 3 here, plus 3. Therefore, alpha plus beta equals minus 5 divided by 4 root 3. Isn't it? Now RHS will take. RHS is minus b by a. Minus of b is what? 5 divided by a is 4 root 3. 4 root 3. Check here from above. Therefore, LHS equals RHS. LHS equals RHS. Now we will go for product of zeros. Alpha into beta equals c by a. LHS alpha into beta equals, what is LHS here? Alpha is minus 2 by root 3 into beta is root 3 by 4, which equals minus 1 by 2. Root 3 cancels, minus 1 by 2. And therefore, c by a equals RHS. C by a equals, c is minus 2 root 3 divided by 4 root 3, which equals minus half. Therefore, LHS equals RHS. Hence, verified. I hope you are able to understand. So, I will take the next problem now. Note it down. I am taking few numericals from exemplar book. One numerical I will take here, which is very typical. I don't remember serial number. I think it may be a fifth one. Note it down. Exemplar 1, 2x square plus 7 by 2x plus 3 by 4. What is that we have to find out? We have to find out the roots here and also establish and verify the relation here. So how to find out the root here? See, one important thing is, if you do not subject it to 0, you are going to have a lot of problem here. As my step 1 itself, subjecting it to 0, my process becomes very simple here. Say for example, let f of x is equal to so and so is equal to 0. To find 0, okay, let f of x equals 2x square plus 7 by 2x plus 3 by 4 equals 0. In the beginning itself, I am subjecting it to 0. Now you have to solve only this part now. Implies, what is the LCM over here? 2 here, which is equal to 4. 4 is the LCM, and this is 1 4 the 8x square, 2 2 the 4 1 the here. This is 1 4 the. So 8x square plus 14x plus 3 equals 0. Implies 8x square plus 14x plus 3 equals 0, because 4 goes that side and it becomes 0. Now splitting the middle term. So I want here 8 3s are 24, and it should be split to get here plus 14. So how do you get 12 into 2, which is perfectly possible, and therefore 8x square plus 12x plus 2x plus 3 equals 0. Take common out of this. Common here it is 4. 4x x plus 3 plus 2x plus 3. Correct? No? 4 2s are 2x plus 3. Here it is simply take one common, which is nothing but 2x plus 3 equals 0. 4x if I take here, 4 2s are 8, 2x plus 3 plus 2x plus 3. It is correct. And therefore, here I will take 2x plus 3 into 4x plus 1, which equals 0. Implies 2x plus 3 equals 0, 4x plus 1 equals 0, x equals minus 3 by 2. So alpha equals minus 3 by 2, and here x equals minus 1 by 4. Therefore, beta equals minus 1 by 4. Okay. So let us see now. To verify the relation now. To verify relationship between roots and coefficients. We have got alpha and beta, and let me write once again here the equation, or shall I populate the values only? That's okay. So what are the values here? I will not take this equation. I can take this equation and prove, or even if I take this equation ABC, the coefficients, it will not make any difference. You will get the same answer whether we take this equation or this equation. So let me take here itself and see whether we can find out these things or not. Let's take A, B, C as here. A equals 2, B equals 7 by 2 and C equals 3 by 4. Now, alpha plus beta equals minus B by A. LHS alpha plus beta equals minus 3 by 2 plus is nothing but 1 by 4 here, 1 by 4. So LCM is 4 here. So minus 6 minus 1, which is minus 7 by 4. Let me check here. 4 is the LCM, 2 2s are 4. So 2 into 3, 6, minus 6 minus 1, minus 7 by 4. Okay, minus B by A, RHS. Minus B by A equals minus of 7 by 2 divided by A is 2, which equals minus 7 by 4. And therefore, LHS equals RHS. Isn't it? Now also, alpha into beta equals C by A. LHS alpha into beta equals, what is alpha? Minus 3 by 2 into minus 1 by 4, which equals minus of minus, plus it is 3 by divided by 8, 3 by 8. So C by A, RHS, C by A equals, what is the value of C? 3 by 4 divided by A is 2, which equals 3 by 4 into 2, which equals 3 by 8. And therefore LHS equals RHS. I hope you have understood how to solve these numericals. Okay, so let me take another one numerical of this type and we'll go to the next type. Okay, note it down. Let me take one more exemplar numerical, sixth one. 2a square minus of 1 plus 2 root 2 times s plus root 2. This is the question here. So, what is that I should take? I have to assume this as a polynomial, no? Is it f of x? Not possible. S is a variable here. So, therefore, to find zeros, let f of s equals 2a square minus 1 plus 2 root 2 times s plus root 2 equals 0, implies 2a square minus 1 plus 2 root 2 times s plus root 2 equals 0. Remember students, very important, this is called factorization method of finding out the roots. Here already my job is done in terms of factors. The first thing you should look for is in such expressions or the equations, can I get 4 terms over here? Check here whether you will be able to get 4 terms. If you are able to get 4 terms, it is already done. Your splitting up of the middle term is done here. In last test, many of you were not able to do such sums basically. Remember that here I am able to split it in terms of, already it is split in terms of 2 terms here, and totally I will be able to make up 4 terms by opening these brackets. Let's see. 2a square minus 1 times s minus 2 root times s plus root 2 equals 0. Take common here, common here. What is common here? Yes. 2s minus 1. Here you take root 2 is a common here. Root 2 minus root 2 is a common. So 2s minus 1 implies 2s minus 1 into s minus root 2 equals 0, implies 2s minus 1 equals 0, s minus root 2 equals 0, implies s equals plus 1 by 2 and s equals root 2, implies alpha equals 1 by 2 and beta equals root 2. So I have got alpha and beta here. Next, to verify the relationship between zeros and coefficients. To verify relationship, what to do? ABC, I will populate the values over here. It is s here. So the entire thing will be a coefficient. Very important thing is this entire thing is a coefficient which is equal to minus b. A equals 2, b equals minus of 1 plus 2 root 2 and c equals root 2. Okay, now alpha plus beta equals minus b by a, which we know. So LHS alpha plus beta equals, what is alpha here? Half plus root 2 equals 1 plus 2 root 2 divided by 2, because 1 2s are 2 root 2. So this is what we are getting. RHS minus p by a. What is minus b here? Minus of, into bracket, minus of 1 plus 2 root 2, the whole divided by a is 2 here. So which equals minus of minus plus 1 plus 2 root 2 divided by 2. Check here, are these two not equal? Isn't it? Therefore LHS equals RHS. Next, product we'll see. The product of zeros alpha into beta equals c by a. So LHS, what is LHS here? Alpha into beta. Substitute the values of alpha into beta. Half into root 2. Half into root 2, which is equal to root 2 by 2. Isn't it? You should be careful under such things, because okay, no problem, let's see here. And what is RHS? C by a. C by a equals, c is how much? Root 2. A is 2. Yeah, we got root 2 by 2. This is also this. And therefore LHS equals RHS. Hence the relation is verified. I hope you are able to understand. Now I am taking type 2 numericals. This categorization is to enable students to understand different kinds of numericals, and if I solve under that particular category some numericals, you will be able to understand and keep in memory also. Okay, if I note it down, I will go to the next type. Here this is type 2, category 2. How to form the quadratic polynomials if the sum and product of zeros is given. General formula: if sum and products of a particular polynomial is given, sum of zeros and product of zeros is given, then how do you form a quadratic polynomial is p of x equals k times, k is a non-zero constant, x square minus sum of zeros into x plus product of zeros. Are you able to understand? This is how we form the quadratic polynomial. So let me take the examples here. First one, from RDS I will pick up NCERT question. 1 by 4, sum of zeros is given to you and product of zeros is given to you. Please remember, sum and product of zeros is given to you. 1 by 4 comma 1. This is NCERT. That means you have been given sum of zeros as 1 by 4 and minus 1 here. Sum of zeros as 1 by 4 and product of zeros is minus 1. Are you able to understand? So how to solve this? How to form this quadratic polynomial? Let us see here. Okay, now given alpha plus beta equals 1 by 4. Dear students, many students will take let alpha equals 1 by 4 and beta equals minus 1. And what they will find? Alpha plus beta and alpha into beta. No, this is wrong here. What is given to you? Already the sum is given to you. Alpha plus beta is 1 by 4 and the product is given to you. That is alpha into beta is given to you as minus 1. If you take these two as alpha and beta, it is wrong. So you must be very careful. See, in order to form the quadratic polynomials, whether the zeros are given or the sum of zeros and the product of zeros is given, that is most important. You must keep in mind. Therefore, we have to read the question very carefully. Here I am reading here. Find a quadratic polynomial each with given numbers as sum and product of zeros respectively. And therefore, sum is alpha plus beta is 1 by 4 and product is alpha into beta equals minus 1. Therefore, polynomial is given by, let p of x be a polynomial. Therefore, p of x is equal to, a non-zero constant is to be taken, into x square minus alpha plus beta times x plus alpha into beta, which equals k into bracket x square, sum of zeros is 1 by 4 times x plus alpha into beta is minus 1, which equals k x square minus 1 by 4x minus 1. Now I want to take this common here. 1 by 4 I'll take a common, which equals k by 4 into bracket 4x square minus x minus 4. You got it? If I multiply with 1 by 4, what happens? 4 cancels, x square, and it is 1 by 4. And here also 4 cancels, minus 1. And therefore the given quadratic polynomial is k by 4 times 4x square minus x minus 4. Check this one. This is how you can find it out. Okay. Sometimes you can stop here also. Here also you can stop. Sometimes you can stop here. But see here, why I am saying you to take this 1 by 4 outside and do this is, please listen carefully. In the last section of this chapter, where we are going to have the numericals on division algorithm. In the division algorithm, sometimes we may have to form quadratic polynomials based on the given zeros or sum of zeros and product of zeros. In that case, if I take this as a quadratic polynomial for division of for dividing a cubic polynomial, it is extremely difficult. Your polynomial should be such that there shouldn't be any fraction in that one. You understand? In that case, you have to take the LCM and eliminate this constant part and only take this as a polynomial. Anyway, these things I am discussing once again. Either you can stop here or here. Both are correct answers. Is it very clear to you? Here what I did, I took 1 by 4 common, and therefore it is 4x square minus x minus 4 here. If you multiply with 1 by 4, you take this 1 by 4 inside, what happens? Divided by 4, x square. Divided by 4, x by 4. Divided by 4, 4 cancels, minus 1. Is it correct? So this is how we can form. Next, second example. Second one. So from let me pick up from R.D. Sharma. Yeah, one more NCERT sum I'll take, and then probably I'll pick up some difficult sums. Root 2 and 1 by 3. Second one. Root 2 comma 1 by 3. Here sum of zeros equals root 2 and product of zeros equals 1 by 3. Therefore, let p of x be a polynomial, and therefore p of x equals non-zero constant x square minus alpha plus beta sum of zeros into x plus product of zeros, which equals k times x square. Sum of zeros is minus root 2 times x plus 1 by 3. You can stop here, but I would like to take the constant out here and try to work out. Take 1 by 3 common, so this is k by 3 here, and here what happens? 3x square minus, if I take 1 by 3 common, multiply it by 3 root 2x plus 1. So this is the quadratic polynomial. Therefore the quadratic polynomial formed here is p of x is equal to, this should be the answer. Let me check the answer. It is correct. Either I can stop here or take 1 by 3 as common here. See, how did I get this? Multiply by this 1 by 3, what happens? So 3 goes here, 3 cancels, x square, 3 cancels, minus root 2x, 1 by 3. It is, isn't it? So I hope you have understood. Let me take another 2-3 problems and we will go to next category. One exemplar problem, I will take it. Root 2 and minus 3 by 2. Third one, root 2 minus 3 by 2. So alpha plus beta equals root 2. Alpha into beta equals minus 3 by 2. So let p of x be a polynomial, and therefore p of x equals k times x square minus alpha plus beta times x plus alpha into beta. So p of x equals k times x square minus, what is alpha plus beta? Alpha plus beta is root 2 times x minus 3 by 2 here. Okay, so take 2 out here, k by 2 into bracket 2x square minus 2 root 2x minus 3. Okay, this is how it is. See, what I am doing here is nothing but LCM. If you are getting confused what is that I am doing over here, see here I am taking LCM. LCM is what? 2. That 2 has come out. So 2x square minus root 2x minus 3. That's what it is exactly. It is taking LCM basically, and finally I am shifting it here. So p of x is equal to, this is the equation. You can stop here. Probably this is the better answer. Okay, isn't it? Let me check the answer. Yes, x square minus root 2x minus 3 by 2. Now also here one interesting fact, he has also asked us to find out the roots here. Are you able to understand? We have to find out the roots also. Remember, the given things are alpha plus beta and alpha into beta, sum of zeros and product of zeros. But what he has not given us? He has not given us the roots. Let us find out the roots here. Okay. Now, to find roots, you have to subject the given polynomial to 0. Let p of x equals 0 implies k by 2 into bracket 2x square minus 2 root 2x minus 3 equals 0. Now this k by 2 entire thing goes off that side. Therefore implies 2x square minus 2 root 2x minus 3 equals 0. So let us have, I'll write here this equation itself. I'll write here 2x square minus 2 root 2x minus 3 equals 0. I require minus 6 here, and I have to split into to get here minus 2 root 2. So I should be able to express 6 in terms of root 2 here, which is nothing but 6 can be written as 3 into 2. So 3 into root 2 into root 2. So minus 3 root 2 plus root 2 equals minus 2 root 2. Isn't it? Therefore, what are the factors here? Minus 3 root 2 plus root 2. Check here. 3 root 2 into root, this is correct. Therefore, implies 2x square minus 3 root 2 times x plus root 2 times x minus 3 equals 0. Take common out of this and out of this. What is common here? Root 2 and x into bracket root 2x minus 3. Isn't it? Here plus 1 you take common, root 2x minus 3, which equals 0. Implies root 2x minus 3 into bracket root 2x plus 1 equals 0. Implies root 2x minus 3 equals 0 and root 2x plus 1 equals 0. So implies x equals 3 by root 2. So alpha equals 3 by root 2, and here root 2x equals minus 1, x equals minus 1 by root 2. Therefore beta equals minus 1 by root 2, and therefore the roots are alpha equals 3 by root 2 and beta equals minus 1 by root 2 should be your answer. So did you understand how did we solve? Here the question was, it's an example question, a little bit twisted. What he has asked here is, he has given the sum of zeros and product of zeros, and he has asked you to form a quadratic polynomial, which I have formed over here, and also he has asked to find out the values of alpha and beta. So how did we do that one? First find out the quadratic polynomial and subject it to 0 in order to find the roots here. And therefore we got finally alpha equals this and this. If you add these two, you'll get this. If you multiply this one, you'll get minus 3 by 2, isn't it? So this is how we can find out. So this is if I are given a sum and product of zeros, and then how to form the quadratic polynomial. Now in this same category, I am taking much more complicated than this one. Dear students, please listen to the lecture very carefully, and you people have to solve yourself in order to form these quadratic polynomials when sum and zeros are given. Now what we'll do is, the new sum and the new zeros will be expressed in terms of the given roots. In that case, how to form the quadratic polynomial, which is a complicated process. So we'll solve few numericals on that one, and you must know how to do that. Sometimes, please remember, here many times we are able to split the middle term and find out alpha and beta, but there are some equations where alpha and beta cannot be found out by splitting the middle term. In that case, what is the method to be adopted is being taught next, and you must concentrate in this lecture. Okay, note on this first. This is the numerical. Please read it very carefully. If alpha and beta are the zeros of this polynomial, find another polynomial whose zeros are this and this. Why you should read carefully? These are the zeros of new polynomial. How do you form a polynomial? You must know sum of zeros. So sum of zeros is this plus this. Also you must know product of zeros, product of this. Once you know the sum of zeros and product of zeros, then you will be able to form a polynomial. How do you form a polynomial? That is x square minus sum of zeros plus into x square minus alpha plus beta into x plus alpha into beta, isn't it? So here, why you have to concentrate in this numerical is, these are the zeros, not the sum of zeros. These are not the sum of zeros and product of zeros, but these are the two zeros for a new polynomial, the name of which can be g of x, which you have to find out. So let's solve it. How to solve this one? Solution. Here f of x is given as 2x square minus 5x plus 7. To find zeros, let f of x equals 0 implies 2x square minus 5x plus 7 equals 0. See, it is not possible to solve this problem by splitting the middle term. What to do here? Let us see one method. Let me check here what is that we will do. It is not possible to split the middle term here. Okay, so what I will do here, erase this part first. Not possible to split the middle term. So we have come across one numerical where we could not split the middle term. Given f of x is equal to this, a equals 2, b equals minus 5, c equals 7. Alpha plus beta equals minus b by a, which is minus of minus 5 divided by 2, which is 5 by 2. Alpha into beta equals c by a, which is 7 divided by 2 here. So we have got alpha plus beta into beta, isn't it? Now these are the new roots. These are the zeros which have been given for a new polynomial to be formed, isn't it? So what we will do is, let g of x be a new polynomial whose zeros are alpha dash equals 2 alpha plus 3 beta and beta dash equals 3 alpha plus 2 beta. I hope you understood here. These are the new zeros of which we have to form a polynomial g of x. Now sum of zeros, alpha dash plus beta dash equals alpha dash plus beta dash. I'll write here, sum of zeros, alpha dash plus beta dash equals 2 alpha plus 3 beta plus 3 alpha plus 2 beta, 3 alpha plus 3 beta plus 2 beta. 5 alpha plus 5 beta, 5 times alpha plus beta. Is it clear? Let me tag it here 1 and tag it here 2 because I am tracing now. 5 times alpha plus beta, I got it. So alpha dash plus beta dash is equal to 5 times alpha plus beta. So alpha plus beta is given here where it is 5 by 2, which equals 5 into 5 by 2. This is from 1, isn't it? And therefore finally I'll write here, therefore alpha dash plus beta dash equals 25 by 2. 25 by 2. Mark this 3. Let us find out product of zeros. Now product of zeros is given by alpha into beta, alpha dash into beta dash, because new product of zeros, alpha dash into beta dash equals 2 alpha plus 3 beta into 3 alpha plus 2 beta, which equals 2 alpha into 3 alpha plus 2 beta plus 3 beta into 3 alpha plus 2 beta, which equals 6 alpha square plus 4 alpha beta plus 9 alpha beta plus 6 beta square, which equals 6 times alpha square plus beta square plus 9 13 alpha into beta, which is equal to, how do you find out alpha square plus beta square? See here, alpha square plus beta square equals what? You express this alpha square plus beta square in terms of alpha into beta. How it is possible? Alpha plus beta, the whole square, equals alpha square plus beta square plus 2 alpha times beta. Therefore alpha square plus beta square equals alpha plus beta, the whole square minus 2 alpha beta. So therefore 6 times into bracket alpha plus beta, the whole square, minus 2 alpha beta plus 13 times alpha into beta, which equals 6 times alpha plus beta, 5 by 2. 5 by 2, the whole square, minus 2 times alpha into beta, 7 by 2. 7 by 2 plus 13 into 7 by 2, alpha into beta, which equals 25 by 4. So I'll try to simplify here. 6 into 25 by 4 here. So 2 3s are 2 2s are. So 75 by 2 I'll write. 75 by 2 here. Is it correct? 25 into 3 is 75. 75 by 2. Okay. Because 6 I am taking multiplying over here. Okay. Minus 2 cancels, 42 plus this is 91 by 2 here. And finally if I work out all this, which equals, let me work out and substitute here. What is the LCM? 2 is the LCM. 2 is the LCM. What is that? We will get 75 minus 84 plus 91, isn't it? So this will be or here you can say 91 84 7 75 plus 7 82 I get 82, which is nothing but 41 here, 82, and therefore alpha dash into beta dash equals, therefore alpha dash into beta dash equals 41 here. Let me check this one. So what did I do here? It is correct. I got alpha dash plus beta dash as 25 by 2 and alpha dash plus beta dash as 25 by 2 and alpha into beta is 41, and this is, mark this as 4 here. You understood? So we were not able to split the middle term and therefore we got like this. Finally what I found out, for a new polynomial g of x, the sum of zeros is alpha dash plus beta dash and product of zeros is alpha dash into beta dash. This alpha dash plus beta dash and alpha dash into beta dash I could able to express in terms of alpha plus beta and alpha into beta, and therefore I got these values. Now we have to find out g of x, and therefore g of x is equal to, here I'll write, therefore the polynomial, new polynomial g of x is equal to, new polynomial g of x is equal to k times x square minus alpha dash plus beta dash into x plus alpha dash into beta dash, which equals k times x square minus, what is alpha dash plus beta dash, from 3, 25 by 2, 25 by 2 times x plus alpha dash into beta dash from 4, 41. So here I'll end this question. Or you can take LCM also. What I can do here, LCM if I take, I'll get k by 2 here, 2x square minus 25x plus 82 is the quadratic polynomial. Do you understand this? So this is very critical. Finally 2x square, let me check the answer here. Yeah, it is 2x square minus 25x plus 82. This is the answer here. So dear students, I hope you are able to understand how to solve such questions. See here, few more I'll be taking something like this, such numericals where you will not be able to split the middle term. You will be able to find out alpha plus beta and alpha into beta. In order to find the new roots, the sum of new roots and the product of new roots should be expressed in terms of alpha plus beta and alpha into beta. Then only it is possible to solve such questions. So please note it down in detail, study this and note it down. Okay, fine students, let me end the lecture over here and we'll see you in the next lecture. Thank you.